Okay. Now, best way to approach these, I think, is to choose values on the graph of f of x, find the location of those points, and write them in a table. So these points I've labeled, and write their locations down. Starting from left to right, we have -2, 0, -1.5, 2, -1, -0.5, okay. Now we need to remember what each of these transformations does to the original graph of f of x. This transformation here, this 2 is inside of a function. Okay, there's a couple of things we learned about a transformation being inside of a function. First of all, it's opposite. It has the opposite effect. Here, the 2 is multiplying the x. The opposite of that would be dividing. Okay, and transformations that occur inside the function have a horizontal effect, which means it's changing the x values. So the x values here are divided by 2. So if we made a new xy input-output chart, we're going to base it off the original chart that we have made here, except all the x values need to be divided in half. So the -2 becomes a -1, -1.5 becomes a -0.75, and then -0.5, -0.25, and so on. And the y values remain unchanged. Now I didn't really provide the best graph here, I'll admit. You can always feel free to change the scale. If you take a look at our x values, they are from -1 to +1 with a bunch of small numbers in between, a bunch of small decimals. So I'm going to actually change how this x-axis is labeled. I'm going to call this -1/2, -1, +1, and excuse me, this is 1/2, and that's going to be 1. I'm going to call this 1, 2, -1, -2. I think it'd be easier to graph this way. Now just plot the points: -1, 0, -0.75, -1/2, 0. Now the effect this is supposed to have is a horizontal compression. It doesn't appear to have been compressed horizontally, but if you look at the original graph, it spans from -2 to +2. This graph spans from -1 to +1, so it has been compressed horizontally. It's just we changed the scale of the axes to make it easier to graph. Now for part B, this transformation here occurs outside of the function. Those transformations affect y values. Since it's not inside of a function, we don't have to do any opposite operations here. What this is saying is take 1/2 of the f of x values. The f of x values are the same as the y values. So 1/2 of the y values. So do that and make a new chart. We're going to use the same x values this time as the original function. But the y values will be cut in half. And I'm going to change the scale again. It's supposed to be 1, 2, -1, and -2. I'm going to change this to -1, and -2, +1, +2. And this acts as a vertical compression because the y values got cut in half, so it's got smashed or compressed vertically. Okay, question 6. It says use synthetic or long division. You really actually don't have a choice. You must use long division because your divisor, x squared minus 2, in order to use synthetic division, the divisor has to be linear. And this divisor is a quadratic. X squared minus 2 is a quadratic, so we have to use long division. Now long division is set up with the dividend inside of a fraction bar and a divisor here on the outside. The divisor and the dividend, if you look, are both missing terms. The divisor is missing a linear term, so I'm going to put in a 0x as a linear term, and the dividend here is missing a quadratic term, x squared. So make sure to put that placeholder in as a 0x squared. Along division, you're focusing on leading terms going into leading terms here. So x squared into 2x to the 5th can go 2x to the 3rd times. So 2x to the 3rd multiplied throughout the divisor is going to be 2x to the 5th plus 0x to the 4th minus 4 x to the 3rd. Draw your line, change the signs. Leading term there cancels, which is what is supposed to happen. 4x to the 4th plus 0x to the 4th is 4x to the 4th. These terms also cancel. Now let's drop down. Now notice how I'm keeping these lined up in columns according to the degree. Okay, that makes things a lot more manageable to organize. Now x squared into 4x to the 4th is 4x squared. So 4x squared times x squared is 4x to the 4th plus 0 x to the 3rd minus 8 x squared. Draw a line, change signs. That cancels. There's nothing here to add. Here we have 8x squared. Now the division is only going to occur one more time because we have an x squared going into an x squared. So this is the last time we're going to have to perform the division, because once we reach here a degree less than the degree of the divisor, we can stop. But since we have two more terms here to drop down, I can drop down both of them. Now x squared into 8x squared is 8 multiplied through draw your line, change the sign. Cancels. Negative x plus nothing is negative x. Negative 5 plus 16 is 11. This is your remainder. So p of x, when it is divided by d of x, results in a quotient of 2x to the 3rd plus 4x squared plus 8 with the remainder Okay, that'll finish up part 1.